So let's try our hands on these questions I have on the screen here. Okay, so the first one is you should find the limit as x approaches 0 for the expression in the root of x plus 3 minus root of x all over x. Okay, so what you are going to do is that you are going to apply L'Hopital's rule here. Okay, you are going to apply L'Hopital's rule here. So we say that you should find the derivative of the numerator and then also the derivative of what the denominator. So let's see what will happen then. So that will be the limit as x approaches 0 for the square root of x plus 3 minus the square root of 3. Okay, all divided by x. All divided by x. Okay, so you are going to apply the L'Hopital's rule here. So first to be able to apply the L'Hopital's rule, let's rewrite this expression here. So that gives me the limit as x approaches 0. That will be x plus 3 to the power half. That's 1 over 2. Okay, minus 3 to the power half. Okay, it's the same as what you have here. I just wrote it in a different way. So all divided by what x. Okay, so now you can now find the derivative of the numerator and then the derivative of the denominator. So let's do that. So we're going to find the derivative of each of them with respect to x. With respect to what x. So that will be d over dx, and then d over dx. Okay, so now let's find the derivative of this. So this will give me the limit as x approaches 0. This will be the derivative of what you have here. You are going to apply the chain rule here. So that will be half times x plus 3 to the power half minus 1. That will be to the power of minus half. Okay, then the derivative of what you have inside, that will be 1 plus what 0. So that will be what times 1. So you can leave that one. And then the derivative of what 3 to the power half. So that since this is a constant, the derivative will be what will be 0. So you can leave that one. All divided by the derivative of x, which will give us what 1. So I then have the limit to be, this now becomes the limit as x approaches 0. Okay, for 1 over 2 times x plus 3 to the power minus half. Okay, so I'm going to rewrite this here. I'm going to rewrite this. Okay, so let me free up some space here. Okay, so that was the limit as x approaches 0. Okay, so I'm going to rewrite this here. So this will be now become 1 over 2 times 1 over the square root of x plus 3. 1 over the square root of what x plus 3 here. So it's the same thing I have it as written in this form. Okay, so now let's see what happens here. So now I can substitute the value of 0 inside. So this now becomes 1 over 2 times root of what x plus 3. Okay. Alright, so 1 times 1 is 1, then 2 times the square root of what x plus 3 will give me this. So now let's put in our value here. Okay. Until you put in the value of 0, you have to continue writing the limit here. So our answer now becomes 1 over 2 times the square root of 0 plus 3. And this will give me 1 over 2 root 3. 1 over 2 root 3. So this will be our answer, which is the C here. Okay, so now let's go ahead and then solve for the second question also. Okay, so we have to find the limit of this expression, which is the limit as x approaches infinity for x plus 2 divided by 9x squared. Okay, 9x squared plus 1. 9x squared plus 1. Okay, so this is what you have here. So you have to evaluate the limit for this. So since it is infinity, it will be indeterminate. So we have to find a way to break it down. So I'm going to use L'Hopital's rule here again. So that'll be, you're going to differentiate what you have on top and then differentiate what you have down here. So that'll be the limit as x approaches infinity. So you're going to differentiate what you have on top there. So I'm going to find the derivative of this. So that'll be d over dx over dx, and then this one also here also d over dx. Okay, so now let's find the derivative of what you have on top. So that'll give me 1 plus 0. And then because the derivative of x is 1 and the derivative of 2, which is a constant, is 0. And then 9x squared, this will give me 18x plus 1. This is what you have here. So with this, our answer is still indeterminate because we don't need the value of infinity. So you have to differentiate again. So that will be the limit as x approaches infinity. Okay, so I'll differentiate what I have on top here, which is 1. So the derivative of 1 now becomes 0. And then the derivative of what? 18x now becomes what? 18. So therefore our limit becomes what? 0 over 18, which is equal to 0. So therefore our limit becomes 0. Okay, so let's look at this question also. That's what we'll be dealing with in this video. Okay, so we've been asked that what expression is the limit below. That's what we've been asked. So let's find out which one of these is it that we can represent as this form. Okay, so before we start the question, let's look at some few things. So when you are asked to find the derivative of a function using the limit approach, and let's say you have a function f of x, okay, f of x, and then you've been asked to find the derivative of this function using the limit approach, that will be f prime of x will be equal to the limit as h approaches 0 for f of what? X plus h minus what? F of what? X, all divided by what? H. So this will be the formula for the first derivative. So for the second derivative also, it will be f prime prime of x, okay, and this will be the limit as h approaches 0 for f prime of x plus h, x plus h, okay, x plus h minus f prime of x, all divided by h. So this is the expression for the second derivative if you want to use the limit approach. Okay, so since you now know about this, let's go ahead and then solve the question here. So what I will do here is that I'm going to break down this expression here. So that's the limit as h approaches 0. So that's f of x plus 2h, x plus 2h minus 2f times x plus h plus f of x plus f of x. Okay, so all this divided by h squared, all this divided by h squared. Okay, so what I'm going to do now is that I'm going to write this expression here. So that be this now becomes the limit as h approaches 0. So that be f of x plus 2h, f of x plus 2h, okay, minus f of x plus h. Okay, see this expression here, I've expanded it, so that will be minus f of x plus h again, okay, plus f of x plus f of x. Okay, so all this divided by h squared, h squared. Okay, so what I have here is the same as this. Okay, the only difference was that instead of me writing minus 2f here, I expanded it here. Okay, so if I add these two, I'll still get what I have here. Okay, so from here, what I'll do is that I'm going to separate these two here. I'm going to separate them so that we have two different expressions here. So I'm separating these two here. Okay, then to get rid of the squared here, I'm going to multiply by h. So I multiply by h. Well, so when I multiply by h, this h can take away this squared here. Okay, so now the squared is now gone. Now let's clean that one. So this squared is no more here. This h2 will be gone. So then you have just divided by what, h. Okay, so now let's see what happens. Now what I'll do is that I'm going to rewrite this expression here. Okay, so this will give me the limit as h approaches 0. Okay, so this will be f of x plus 2h, f of x plus 2h minus f of x plus h. Okay, so I write this all divided by h, all divided by h, and then minus this one. I'll bring it out of the bracket, so that will be minus f of what, x plus h, and then minus f of what, x. Okay, so all this divided by h. Okay, so this is what I have now. Alright, so okay, just want to clean some speed, then we continue. Okay, so from here, let's look at what will happen. So from here, what I'll do is that I'm going to find the LCM here, which is 8. Okay, so I'll find LCM here. So I now have what, h here. Okay, alright. This order we need, then we are good to go. Okay, so now let's look at something here. Okay, I'm going to take away the question for some time. Okay, so now let's look at something here. So we have what, f of x plus 2h minus f of x plus h, and then you have what, f of x plus h minus what, f of x. Okay, so now look at this here. When you see what you have here, okay, what you have here is the same as what, f prime of x, which is what, f of what, f of x plus h minus what, f of x over h, right? So you can clean all this and then kind of put f prime of x there. So I'm going to clean all this. I'm going to clean all this here, and then now I'm gonna write f prime of what, x there. So that will be f prime of what, x. Okay, so now write f prime of x here. Okay, so now what about this part also? So that one to give me when I have f prime of x as h. Okay, when I have f prime of x plus h, and then I'm using this approach here. Okay, I'm using this same approach here. Okay, so this will give me f of what, x plus h plus h. Okay, so this is just like, you see how you have just x here, and then we added an h here, okay, which is the distance here. We added this h here. Okay, same way here, but here you see we had h here initially. Okay, before you still have to add another h here. That's why I have two h's here. So this minus what, f of x plus h. Okay, so you see that was the same thing that is happening here, just that here the value that was in this bracket was just x. That's why I added just h here, but in this case we have what, h already here, so we added another h. That's why it has become double h here. Then later on we can put this x plus h here in the second bracket here. So all this divided by h, all this divided by what, h. So that will be the first derivative of this. Okay, actually I was supposed to write limit here, so let me take this one off here. So that be the limit as the limit as h approaches 0. Okay, that's for f prime of, this is for f prime of x plus h, f prime of what, x plus h. So since we have this here and this equals f prime of h, we can come and substitute it in place of this. Okay, so you see that what you have here will be the same as what you have here. Okay, so let me actually simplify this, what you have in this bracket here. So this is what, h plus h, so at the end we get what, 2h here. So then you can write 2h there, so that then we have what, 2h. Okay, so you see that what is just the same as what you have here. So instead of you writing this, we can kind of write f prime of what, h, f prime of what, x plus h here. So now let's do that. Okay, so this is 2h, this now becomes to 2h. So you're going to substitute this guy here instead of what, rewriting this here. So let me clean that one here. Okay, so this is what you have. So now you have what, f prime of what, x plus h minus what, f prime of what, x all over what, h. Okay, so now let's come back to what we did from the beginning. So looking at what you have here, okay, look at what you have here. You see that what you have, what, f prime of what, x plus h minus what, f prime of x all over what, h, and this is equal to what, the second derivative of what, function x. So it's the same thing that I have here. So this is equal to f prime prime of what, of x. So now let's go back to the question and then look for our answer. So instead, what expression is the limit below? So you will now find out that what is the second derivative of the function f of x. So this will now be our answer.